start with our beautiful first semester study guide. We are going to start with number 1. And yes, it's multiple choice. However, I don't want you guys to get distracted with this option. So what I like to do is I like to block out my beautiful multiple choices for one, so I can go ahead and have enough space to write down. Now, you guys can write on this packet. This packet is yours. You guys can write yourself notes, whatever you guys need to study, but make sure that you guys study, okay? So it's not just learning the procedure and just learning how to do this particular example. Learn how to do this. Yes. Are we going to be similar, like very similar in format? Let me go ahead and say that. Maybe yes. Oh, okay. Yeah, sure. Yes, so I have it exactly like that. Pues you have to get better studying habits, because you need to learn how to study, right? All right. Now, whether it's for here for another subject, guys, you guys need to learn how to study. And I'm giving you guys a study guide. Okay. Guys, I'm giving you guys a study guide so you guys can have something to guide yourselves in your study habits, okay? So, first one, we're going to go ahead and solve. We have x minus 13x minus 7. And our beautiful binomials to the power 2 equals 110. Now, what do you guys see here? Exponent. So notice here that everything is inside our beautiful exponent. Let's go ahead and get rid of that. How do we get rid of that beautiful exponent? Not distribute. Square root. So square root one side, square root the other side. This is called a square root method, guys, and we've done these before. So what happens, my beautiful square, eliminates the square root. So we're left with 13x minus 7 equals, again, whenever we take the square root of something, it becomes the plus and minus square root of 110. Now, 110 is not a perfect square, so we're going to go ahead and leave it as that radical, okay? Leave it as a square root. Now, our goal here is to isolate that beautiful x. So how do we isolate it? Very similar to our two-step equations, guys. Add 7. So add 7. Eliminates my beautiful 7 on my beautiful left side. We're left with 13x equals, I always like to write my constant in the front of a radical. So I have 7 plus or minus square root of 110. We still haven't isolated that beautiful x. So what's the last step? Divide by 13 on one side, divide by 13 on the opposite side. So that goes to 1. So we're left with x equals. Now notice that we have a positive and a negative sign. That means that we have two solutions. The first one is 7 plus square root of 110 divided by 13. The second one is 7 minus square root of 110 divided by beautiful 13. So which one is our beautiful option here? You guys have them in front of you. D or B? B. So make sure that you guys select your option and write your option on the side. What if you Googled it? Oh, circled it and select. I want to make sure you guys are able to select. Huh? Yeah. All right, so let me go ahead and clear. Remember that we were doing the square root method, guys, and we solve. So let me go ahead and clear. Move on to numero dos. So numero 2, guys, we're going to go ahead and complete the square. So we're given the example of x to the power 2 minus 14x plus our beautiful open space. Then we're going to go and write the resulting expression in a binomial square. So basically, we're going to factor it, okay? So if you guys remember completing the square whenever I showed you guys a geometric figure, you guys were kind of confused when I showed you, but it was your beautiful square like this. And then you were missing that little piece, right? I showed you guys. Now, that little piece represented something algebraically. It was that b divided by 2 to the power of 2. Okay, so that's how we are going to complete that beautiful square. That's what we're missing here. Okay, now I'm going to use that b divided by 2 squared. Now, the way that we're going to go ahead and do this is that beautiful open space. Now, remember that we have a beautiful quadratic, so my first term is always going to be ax squared. My second term is going to be bx, and the last one is going to be c. So what is the b value in this example? B is going to equal negative 14. There you go. So let's go ahead and substitute into our b divided by 2 squared. So negative 14 divided by 2 squared. So negative 14 divided by 2 squared, 49. So what goes in our beautiful square to complete it? 49. Now we need to write an expression as a binomial, meaning 2 terms. So let's go ahead and write it down here. X squared minus 14x plus 49. And let's go ahead and factor it. So how do we factor Power Ranger method? 2 numbers that multiply to 49 and negative 14. Remember that they have to be the same values. Negative 7. So therefore, it's going to be x minus 7. X minus 7. However, since they repeat, in order for us to write them down as a square, all we have to do is just write them once to the power of beautiful 2. So completing the square was 49. It's factored form as a binomial square, meaning 2 terms squared is what? X minus 7. So our option is C in this case. So be careful whenever you select your options, guys. Be very careful. Now, the reason why I'm going to ask you guys to show your work is because there's going to be times where you guys select the wrong answer. But if I see your answer or your work correctly, guys, I can go ahead and give you guys partial credit. Okay. So I want to make sure that everything is shown correctly and vice versa. If you select the right answer, but didn't show your work, guess what? 0. No. 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 No work, no credit. No work, no credit. Even if it's right, I need to see. That's why I said partial credit. If the work is right, the answer is wrong. Partial credit. A ver. Okay, so okay, let's go on to the next one, guys. Número 3. Quedamos así. So be careful, please. I know the test anxiety gets the best out of us, guys, but it depends. It depends. I need to see. Yeah, you can draw on the test. Okay, here we go. Listos. Guys, I can either give this to you guys to do it on your own and figure it out on your own, or I can continue going. I need it quiet, please. Thank you. So, next example, guys, we have negative 4x squared equals 5x plus 9. So, let me go ahead and write it down so I can have it down here. 4x squared equals 5x plus beautiful 9. We have a beautiful quadratic. How do we solve quadratics? You can use that quadratic formula. But what do we need to do to our beautiful equation? We can factor as well. We need to make one side equal to what? 0. So let's go ahead and do that. How do we make one side equal to 0 for this example? Let's go ahead and add 4x squared. Add 4x squared, add 4x squared. This goes to 0, guys. Pay attention, please. We have our left side equal to 0. Our right side is going to be 4x squared plus 5x plus 9. Notice here that my 0 is on my left side. I don't like seeing it like that, so I'm going to go ahead and rewrite it on the left side, on the right side. Everything, I'm switching them sides. Can I do that? Yes, I can. Okay, perfect. All right. Now, from here, what method do you guys want to use? Remember that we did those beautiful posters? Okay, let's try Power Ranger. So we have a leading coefficient that is not 1, so we need to multiply 2. So we have 4 times 9 is 2 numbers that multiply to 36 and add up to 5. 9 and negative 4. Okay, let's see. 9 times negative 4, does it give me positive 36? No. 6 times 6 is 36, but add them together, does it give us 5? No. So can we find any numbers, any factors? No. So the next part is to what? No. Use the what? Quadratic formula. Quadratic formula will never fail you guys. So if you guys remember the quadratic formula, B equals, I'm going to go ahead and play that song for you guys again. B equals negative what? B plus or minus square root of B squared minus 4AC all over 2A. A ver, let's see if you guys can remember your A, your B, and your C. Here's my formula. Here's my equation. We have 4x squared plus 5x plus 9. My A is what? My A is 4. My B is 5. My C is 9. Okay. So let's go ahead and plug in everything into a beautiful equation. Yes. So you can see what I'm doing. What's the difference? What is pushing? So this is my quadratic equation, or the quadratic that I'm using. I wrote it over here, and then I'm identifying A, B, and C. I can just use any colors. Okay. Do you want me to leave everything in one color? Okay. No, yeah. It's just so you guys know where the A, B, and C is coming from. All right. Guys, I need it quiet, please. Now, x equals what? Negative what? 5. Negative 5 plus or minus square root of 5 squared minus 4 times 9 all over 2 times beautiful 4. Okay. Now, this is where you have to be very careful, guys, in simplifying. So, x equals negative 5 plus or minus. Inside of my radical, 5 squared is 25. Negative 4 times 4 times 9. So, negative 4 times 4 times 9. Negative 4 times 4 times 9. 144. There you go. Thank you, guys. 144. All over 2 times 4 is 8. Okay, we're still not done, guys. X, we still have to continue. We have to simplify instead of radical. Ah, goodness gracious. Well, that's why you guys have to study and practice. Okay. So negative 5 plus or minus square root of 25 minus 144. I'm only combining these two guys, these two terms. 119. There you go, 119 all over 8. Now, something that I want you guys to look at. Notice here that I have, guys, I need it quiet, please. Notice here that I have a negative sign inside of my radical. Anytime there's a negative sign inside your radical, that means that we have no solutions, no real solutions. No, you guys found out that there's no real solutions. We're going to learn about these cases next semester, guys. Because you have to go through the quadratic formula to find that out. Yes, exactly. Okay. So again, we couldn't factor it. We couldn't find perfect factors, so we tried the quadratic formula. So in this case, it's what? Okay, I'm gonna go and continue. Everybody has this. Okay, awesome. Numero 4. All right. So whenever it's asking us to find zeros, guys, again, quiet. Let me go ahead and cover my solutions. I don't want to see them for right now. Now, whenever I'm being asked to find zeros, it means that I'm being asked to find solutions. So remember that whenever we introduced these, we had them as a form of y equals x squared plus 7x plus 9. We had y. We had to make y equal to 0. So we're going to go ahead and let y equal to 0. We have 0 equals x squared plus 7x plus 9. Now, I don't like to see my beautiful quadratic on my right side. I always like to see it on my left side just so I can see what I'm doing. And again, you can leave it as is. Clarissa, focus, please. And I can go ahead and write it this way. Now, from here, you guys did beautiful posters. Which method do you guys want to use? Do you guys want to try factoring again? Okay, factoring just in case. Let me see. We have a leading coefficient of 1, so all we have to get is 9 and add up to 7. So 2 numbers that multiply to 7 and 9 and add up to 7. Do we have any? No, right? So what do we have to use? Quadratic formula. So again, guys, I need to quiet. X equals what? Negative b plus or minus square root of b squared minus 4ac all over 2 times a. Ahí está. Okay. What's my a? 1. What's my b? And my c? 9. A ver. Let's see if it works this time. X equals negative 7 plus or minus square root of 7 squared minus 4 times, I need it quiet, guys. 1 times 9. This all goes inside your beautiful radical. Over 2 times beautiful 1. Okay. All right. Simplify inside of your beautiful radical. So we have negative 7 plus or minus 49 minus 4 times 1 is 4. 36. Am I going too fast? 2. All we did is multiply 7 times 7, so we have 49, and then negative 4 times 1 times 9 is negative 36. Okay, so simplify those two things, so 2 terms. Okay, continue. Negative 7 plus or minus 49 minus 36. So square root of 13 over 2. Square root of 13 is already a prime number and it's not a perfect square, so we leave it as is. So remember that whenever we have a square root, we have plus or minus. So we have 2 solutions. The first one's going to be negative 7 plus square root of 13 over 2. And the second one is going to be negative 7 minus square root of 13 over beautiful 2. So this one, there is a solution, but it's a decimal form. We can leave it as a radical. And we will be able to find the beautiful solution. So which option is this one? It's covered on my side. Is it B or C? B? Oh yeah, because A doesn't have over 2. So this one is B. A ver. I sent an image. I'm going to post this on Canvas, guys, so you'll have access to the video, the recording, and the work. So you guys make sure you guys study. Okay? So study. Ryan, study. Yeah? Okay. Yeah, Ryan? Yeah, okay, perfect. Okay, número 5. Ready. Okay, now, these type of examples, guys, you most likely saw it when we did Mathia. So this is when we had our beautiful area perimeters and those type of examples that we had to apply. This time we're working on polynomials, and we have to model the polynomial in order for us to identify what it's asking for. Okay, so we're gonna go ahead and find what the values are according to what we're given here in the specifications. So we're given a rectangle, and it has a length of what? X, and a width of 5x to the power of 3. You're gonna miss it. Plus 4 minus x squared. Now, we're given the challenge of finding the perimeter of the beautiful rectangle when the length is what? 5 feet. So let's go ahead and draw my figure. What kind of figure do we have? A rectangle. Now, if you guys remember the properties of a rectangle, opposite sides are congruent. So I have one side measuring x. So I'm going to go ahead and label this one as x. And my width measuring as 5x to the power of 3 plus 4. That looks ugly. Let me write it prettier. Plus 4 minus x squared. Now, properties of rectangles, opposite sides are congruent. So I'm going to go ahead and write my beautiful measurements for the other sides. Yes, they're represented as algebraic expressions. However, the idea still remains. Now, perimeter. How do we find the perimeter of a beautiful rectangle? What do we have to do? We're going to go ahead and add all the sides together. So I'm going to go ahead and write this as a function. So my perimeter is going to be depending on the value of x, since we have a variable. And if it's a perimeter, I am going to add all the sides together. So I'm going to start with x. My first side is x plus. My second side is 5x to the power of 3 plus 4 minus x squared. My next side is x, so plus x. And the last side is 5x to the power of 3 plus 4. That plus looks like a plus 4 minus x squared. So again, if you guys don't see it, we have one side, the next side, and the last side. So we should have 4 sides added together. And they just happen to be expressions, okay? Now, let's go ahead and simplify. Let's go ahead and combine like terms. So I have my P of X equals, what combines together? Okay, let's start with our highest terms. 5x to the power of 3, 5x to the power of 3. Combine them and I get 10x to the power of 3. What are our next terms? Negative x squared and negative x squared. Combine those and I get a beautiful negative 2x squared. My next terms that combine, x and x. We have beautiful 2x, so plus 2x. And the last one is my constant. Yeah, I have 4 and 4. Beautiful 8. So plus 8. Okay. Now, we're given a condition. Our length has to be what? 5. What is also our length? So x has to equal what? So let's go ahead and let x equal 5. So we're going to do now the function p of, instead of writing x, we're going to write 5. And for every x value, we're going to go ahead and substitute in 5. So it's 10 times 5 to the power of 3 minus 2 times 5 to the power of 2 plus 2 times 5 plus beautiful 8. Okay, let's go ahead and evaluate that. P of 5 equals. See, 5 to the power of 3 is it 125? 5 times 5 times 5, 125. So this is 125 times 10. There you go, 1,250. Negative 5 times 5, 5 to the power of 2. Negative 100, yeah. No, negative 50. But yeah, negative 50. The next one is positive 10 and positive 8. So let's go ahead and combine all these values. So 1,250 minus 50. 1,200 plus 10. And plus 8. 200. And beautiful 18. So our perimeter when x equals 5 is beautiful 1,218. And this is feet. Woo! Not too bad, right? This one we added and subtracted polynomials. Add, subtract polynomials. Let me save an image before I forget. Number 5. You need to hurry up. 1218. Feet, Whenever I write with the pen, for some reason las se juntan. First, I don't know why. Like, for example, whenever I write a T, a veces cuando lo hago chiquito se me aparece 4. Se junta. I don't know why it does that. It just, there's a little glitch. But it works. It works. Okay. All right. Everybody has that? ¿Se va la una? ¿Se va las dos? ¿Se va las tres? Okay, here we go. All right, number 6, guys. This is bringing us back to our beautiful identities that I made you guys learn, if you guys remember. So, identities. We had several of them, but these are the ones that we're going to go and recall. So the first one, we had x and y to the power of 2. And it had a result of your x value being squared plus x, 2 times x times y. So 2 times x times y plus y beautiful square. Next, we had the differences of your beautiful factors. So if we imagine that we have x plus y or x minus y, and it gave us the result of our differences of squares. We went over that when we went factoring. And the last one that we went to is similar to the first one, except that we are now writing minus. So y minus, x minus y squared. And it's giving us a result of x squared minus 2y plus y squared, okay? Now, we're going to go and use either of these beautiful identities so we can rewrite the value, rewrite the base, and it can model one of the beautiful identities. So, which one do you guys want to use? The first one? Okay, the first one. All right. So if it's the first one, I need to rewrite 23 as the value of 2 numbers that are adding together. So what 2 numbers do you guys want to select? Well, it has to be 23, but 2 numbers that give you 20. It can be 10, 13, 20, and 3 squared. Okay, so let's go and try this one. So again, if you want to use this one, rewrite it so that it's two values that add up together and give you the sum of that beautiful number. Now, if we were to use the second one, two values that subtract each other and give you that number, an example would be, for example, let's say 26 minus 3 or anything else that you guys can think of, okay? All right. So let's go ahead and see. It gives me my X and my Y. So we're going to go ahead and use that same beautiful formula. X plus Y squared. We have to use the formula X squared plus 2XY plus Y squared. My X in this value is what? 20. So I'm going to be using 20 squared. Let me use the same color so you guys can see it. 20 squared plus 2 times, what's my X? 20, what's my Y? 3, and my beautiful Y squared. So it's 3 squared. So let's go ahead and compute that. 20 squared is 400. 2 times 20 is 40 times 3, 120, and the last one, 9. So what is 400 plus 120 plus 9? 500 and beautiful 29. Separating it. It's using the identity. It's using the identity. We're using the identity to do this. You have to use the identity. Sí. Ay, Dios mío, estudiar se ha dicho. ¿Ya? Okay. Sí, bien. Go ahead, Diane. Okay, let me go ahead and clear. All right, we're skipping number 7, guys. I'm skipping this one. No, number 7. I said 7, skip. So go ahead and skip this one, please. We're gonna skip. No. And the last one for today. Muchachos. Thank you, Nadi. Okay. Guys, I need it quiet, please. Muchachos. Guys. So, number 8. We're going to go ahead and use our beautiful binomial theorem. Do you guys remember this one?
Yeah, it's the 1, 2.
Our beautiful triangle. So we're going to go ahead and bring back our beautiful Pascal's triangle. We start with 1. Our next row was 1, 1. The next row was what? 1, 2, 1. The next one is? 1, 4, 6, 4, 1. 1, 5, 10, 10, 5, 1, and so on and so forth. So remember that our first row, it was what? Row 0, row 1, row 2, row 3, row 4, and row 5, and continues on and on and on. Okay. Perfecto. Now, we're going to go and use the binomial theorem to expand each power of the binomial. So we have x minus 2 to the power of 4. Which row are we going to use? 4. Why? That exponent is beautiful 4. So I'm going to go ahead and use those coefficients. So I need 1, a little bit of space. 4, a little bit of space. 6, a little bit of space. 4, a little bit of space, and the last one is 1. All right, so now, in our beautiful binomial, guys, we have 2 factors. We have our first factor, which is what? X. We're going to go ahead and write that factor. X, 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 X. Okay. My second factor is not a cheeseburger. -2, -2, -2, -2. and -2. Okay, now remember that our beautiful degrees, guys, they start from the highest degree that we have here. So we're going to start 4, and then it's descending, meaning that it goes down. So it goes 4, 3, 2, 1, and 0. And the other one is going to ascend. So I'm going to start from 0, 1, 2, 3, and 4. Okay. Now that we have everything, now we can go ahead and carefully simplify each term. So my first term right here. Let's go ahead and simplify. We have x to the power 4, -2 to the power of 0. What is -2 to the power of 0? 1. So we have 1 times x to the power of 4, x to the power of 4. Okay, so we have -2 to the power of 1, -2, -2 times 4, -2 to the power of 4, I mean, -2 times 4, thank you, 8.
I guess.
Close. Guys, -2 times 4? -8, so this is -8x to the power of 3. Dios mío, me van a juntar más fácil. Okay, next one. -2 to the power of 2. -2 to the power of 2. Close. 4. 4 times 6? 24x to the power of 2. -2 to the power of 3. -2 times -2 times -2. -8. -8 times -4. Sorry, +4. -32x. And the last one, -2 to the power of 4. 16. 16 times 1 is, and x to the power of 0 is also 1, so times 1. Beautiful 16. And there you go. Yeah, better? Let me save an image. Thank you, Mikey. Everybody has that? Not too bad. Está bien. ¿Un qué? Un mito.